One of the things we covered in chapter 19 so far was the speed of sound, and we mentioned that it was about 770 miles per hour or 340 meters per second. What we didn't do is talk about this time delay between lightning and thunder. You've often heard that if there is a 1 second time delay between when you see lightning and hear the thunder, then, well, we've often heard that it's a 1 mile distance, but it turns out to be a lot worse than that. As we can see here from the speed of sound, a 1 second time delay between lightning and thunder is about 3 football fields away. So 340 meters. And that corresponds to about 1/5 of a mile. I remember there was a fifth grader given a science report one time at a grade school, and I was judging that science competition. And I remember him saying that if there was a 2 second time delay between when you see the lightning and hear the thunder, as you can see from this equation, not equation, but value here, if it's 2 seconds, the fifth grader said it's 680 meters away. And the fifth grader went on to say, if it's a 1 second time delay between when you see the lightning and hear the thunder, then it's 340 meters away. And I was so happy that he said that. But then he went on, and this was clever. He said, if there's no time delay between when you see the lightning and hear the thunder, never mind. So I thought that was kind of clever. You got hit if there's no delay. So here's a couple of lightning strikes here. Let's see if we can hear any of it in the background. Okay, so you can see maybe 1 second delay or something like that. So in summary here, if we're looking at it and we see that there is a 5 second time delay, then it's going to be a mile. But if it's 1 second, it's really about 1/5 of a mile or 3 football fields away. We've seen some bold terms in chapter 19 with subsonic being slower than the speed of sound, subsonic being faster than the speed of sound, a little more exciting there, and of course the Mach number being the speed of the object divided by the speed of sound. So Mach 1 corresponds to something being exactly the speed of sound, and Mach 2 corresponds to being double the speed of sound. When aircrafts go faster than the speed of sound, some odd things happen. You get this shock wave back behind it. Let me see if I can find some interesting images of some shock waves. I want to pause the video. So this is an image taken with the camera that was able to capture the shock wave both in front of and behind a bullet, and here's one in front of an aircraft. As you'll see in some of the figures in your textbook, when these aircraft travel faster than the speed of sound, you get a pressure wave in front and behind. So this shock wave, the definition of that is just a cone-shaped pressure wave that's created by an object going supersonic. And when this leading edge of the pressure wave hits a person right here, if they're far enough away, they'll hear this and that. But if they're really close to the aircraft, normally the leading and the falling pressure waves are not distinguishable. As it says over here, you have a high pressure bow wave from the front and a low pressure from the rear. And the aircraft doesn't have to be noisy in order to make this sound. I think I have a video, let's see. Yeah, so here is a case where you have the person only here in that location hearing the shock wave there. As I mentioned in class also, the crack of a circuit swip is going faster than the speed of sound. I'm going to see if I can find a video of that in just a moment. But first of all, I want to let you listen to the two booms, the sonic booms coming from an aircraft, not an airplane, but rather the space shuttle. So let me pause the video. All right, so this is the sky. You can barely make out the space shuttle, the bottom of it, and the tip of it here, and the tail over here. NASA logo up there. This is taken with a telescope, so it's when the space shuttle was very far away. I'm going to play the video, and hopefully the sonic boom will play through. And so you saw in that case that there was a significant time delay between the two booms. and that arises from the leading and falling edges of this pressure wave.